Okay, so take a look at the graph, the piecewise function that's graphed here, and you notice that there are three segments. And so what we have to do in this problem is come up with the formulas for each one of these segments. So you notice here f of x is equal to, and we have these three lines, and each line will represent the formula for the segment that's graphed here. So first, recall that when you have a piecewise function, the first part of the formula is for the y values, and that's like your output. And the second part is the rules, the guidelines for your inputs. So depending on your choice of x, it'll determine which one of these lines that you use the rule to follow to determine your y value. So let's take a look at the first line. Let's see this first segment here, and try to come up with the guidelines for the x input. So notice here that each of these have closed circles. Okay, so that means that you're going to have values that you're going to have a inequality has an equal sign underneath it. And let's go ahead and find the values first of the endpoint. So x is the furthest, the lowest value is -6, and then the highest value is what, -1. All right, so I know that my x has to fall in between these two values, right? It has to in between -6 and -1, and of course the question is, can I include -6 and -1? Yes, because these are closing circles. So that means I have these less than or equal to inequality signs. So the way this reads is x can be it's going to be greater than or equal to -6, or less than or equal to -1. Okay, once again, it's less than or greater than or equal to -6, and it has to be less than or equal to -1. Right? Now the y value, and let's go ahead and this will be rule number 1. Right. So for the y value, notice that we have a line it has a slope, it's sloping down. This is a linear equation. So the first thing for my rule number 1, I notice that the slope of this thing, since it's sloping down, it's going to be negative. And slope, you can just use the graph to determine the slope. You can pick 2 points and use your slope formula, or you start, and I can start at the end point here, and I count, okay, how many, remember rise over run, so how many steps up or down am I going? So I'm going down 1, and then I'm going to the right 1, or I'm running 1. Down 1, over 1. So this is 1 over 1. And when I reduce this, I end up with -1. So now to find the rest of this, the equation of this line, or the segment, the equation of the line that the segment falls on, then I can use the point slope formula. So let's see, we'll use a point. Let's use the same. We'll use this endpoint, and that is -6, comma +3. So when I set this up in point slope form, I get y minus 3 equal to -1 times x minus a -6. Okay, so this is y minus 3. Well, let me actually, so you don't get confused with too many equal signs. Put this here, comma, y minus 3, and then I get what, negative, now you don't have to write the 1, so -1 x plus 6, and then y minus 3 equal to -x minus 6, and then finally it's y, when I move the 3 to the other side, y equals -x minus 3. Okay, so this is the line that segment falls on. I know that it doesn't, This is in slope-intercept form, and it's saying if I was to extend this line, it would cross at -3. But because the x, the domain is restricted to between -6 and -1, we're only going to get this segment, right?